Ohio University is looking to offset their Laoshi energy plant, which is currently producing 2,500 tons of cooling load. To do so, we are going to use an abandoned mine about 2 miles away from OU.
To achieve this goal, the abandoned coal mine will act as a heat sink for a geothermal system. This system would be a closed-loop design where the water would be extracted from the well using ground source heat pumps. The water would then be returned and injected back into the well at a different depth. The water would be extracted from a well located at a depth of 400 feet, while the injection well would be at a depth of 3,900 feet. The water then leaves the mine at a temperature of 11 degrees Celsius, where it is treated using reverse osmosis, since the mine water may contain high total dissolved solids, making it acidic. Thus, this removes these impurities and raises the pH of the water. Heat exchangers located at the Laoshi plant will cool a heat transfer fluid which cools the building on campus during the summer. After cooling, the water then returns to the Laoshi energy plant and eventually pumped back into the injection well at 15 degrees Celsius.
Here we have our system risks and where they lie on a conventional energy impact and visibility map. For every geothermal power system, there are a few risks that need to be addressed before any money can be spent. These risks can either delay or completely stop the project from moving forward depending on their severity. As you can see in the right graph, the risks with the largest impact include accessibility and unknown quality of the mine. By circulating old coal water, we can bring up harmful chemicals. However, our mine being a closed-loop design means the water coming out will go right back in without ever coming into contact with clean water. Also, as you can see from the chart, there is often high risk in drilling into the mine for the first time. Often, great economic risk is associated with drilling, and although the technology for drilling is well known due to oil and gas rigs, if one were to miss the mine in their first hole, that is a few $1 million sunk. Fortunately, with our mine being so large and the mines in this region being mapped, the chances of us drilling for our mine and missing it are little to none.
The mine chosen was AS029 because it was the closest mine that was sufficiently sized. The pipeline carrying the mine water is going to run through only publicly owned land, running along the Hockhocking Bike Trail. Heat exchangers will be located at the Laoshi Energy Plant. There's going to be 3 years of construction, including 2 years of drilling, before we expect a 7-year payback period. The project will be managed by OU Facilities.
Geothermal leasing and permitting on federal land is managed by the U.S. Bureau of Land Management. At the federal level, tax incentives are considered one of the most important incentives for driving growth in renewable energy. The American Recovery and Reinvestment Act increased federal funding, loan guarantees, and tax credit for investment in energy efficiency and renewable energy, such as the Advanced Energy Manufacturing Tax Credit. The Rural Energy for America program provides financial assistance through grants and loans for entities that purchase and construct renewable energy systems. Total aid is limited to 25% of a proposed project's cost, with a maximum of $250,000 in grants and $25 million in loans. At the state level, the most important laws are the Renewable Portfolio Standards that require utility companies to have a growing percentage of renewable power generation in their mix. Using geothermal energy will meet Ohio's Alternative Energy Portfolio Standard. The Supreme Court of Ohio also confirmed that abandoned mine water is legally able to be used in Ohio based on water rights and legal precedents, unless the withdrawal of groundwater unreasonably causes harm to a neighboring land.
The total installed cost of this project will be around $39.7 million, with 91% of that cost coming from laying down the pipes for the water to go to the mine and back. The other costs mainly come from pumps, heat exchangers, the heat pumps themselves, as well as housing all of the facilities. The levelized cost of energy is about 10.55 cents per kilowatt hours, while the average yearly revenue is almost $8 million. The payback period with 0 grants with an ideal condition will be about 6.54 years. Now, if we were able to get this funded by 20%, that would go down to 5.2 years. If you wanted a true 5-year payback period, that being 3 years of construction and 2 years of payback, it will be about 84% funded, or around $33.5 million. In conclusion, we don't see this as a viable option without an incredibly high budget. And with a 10.55 cents per kilowatt hour, it does not compete with traditional natural gas.